All right. Hi, folks. This is Mr. Bakas here. I'm hoping that you can hear me nice and clear. Just recording this. I know that we went over this lesson a little bit earlier this week, but I just wanted to re-record it just in case you wanted to go back and check over it later. So today we are going to go back over our presentation for evaluating expressions. So starting from the beginning here, if you want to pause at any point for any clarifications, or if you want to take down any notes, please feel free to do so. But again, we are talking about evaluating expressions. So I have an algebraic expression right here. I have 5p plus 4. So we're going to go over some of the vocabulary terms. So things are pretty much color-coded here if you look. So the terms are the individual parts of an expression. My terms here, I have 5p and I have 4. My coefficient is a numerical factor of a term that contains a variable. So what that means is, it is the number in front of a variable that tells you how many times you are going to multiply that variable. So 5p, okay, stands for 5 times p. The variable is a symbol, typically a letter, that represents an unknown, okay? We have talked about variables in terms of x a lot, but remember that a variable can be pretty much any letter. So here it is p. Then I have a constant. So constant is that 4. Constant is a term with no variable. It is known. So call it a constant because it is going to constantly have the value of 4. It doesn't change at all. So again, move on to the next slide, but please feel free to pause at any point if you want to take down these notes. So continuing on with the vocab, we have variable expressions, aka algebraic expressions. So an expression such as n minus 5 that consists of one or more numbers and variables and one or more operations. So if we look at the expression n minus 5, n is our variable, the subtraction sign is our operation, and we have a constant right here that is 5. So it is not an equation, is an expression. The difference between an equation and an expression is the presence of an equal sign. Equations have an equal sign. You know, they use the EQU right there at the start of the word, and expressions do not have an equal sign. How do we evaluate a variable expression? We are going to write the expression, substitute a number for each variable, and simplify our results. Substitution is replacing a variable with a given value. So if I tell you that n is equal to 7, then you will replace every n that you see with the value of 7. So again, just another example of a variable expression. I'll go to the previous slide, 5p plus 4. You see there that we have a variable, we have a constant, and we have an operation, that addition right there. Moving on, we're going to look at this chart here, and it's going to tell us what are some of the different ways that we can describe a variable expression. We have operations here. 5x. When we see the coefficient 5 in front of the variable x, it's going to mean 5 times x. That is multiplication right there, as you will see for our operation. A couple different ways we can represent that. It can just be 5x. It can be 5 times x with a dot, 5 parentheses x, and you can also do 5 times x with multiplication being represented as an x, but that gets a little bit confusing just because, you know, there's too many x's. Looking down, we have division. So 5 divided by x is how we would say this. 5 divided by x can be represented as a fraction with 5 over x, or it can be just using the operation symbol for division, 5 divide x. Again, going down, we have addition, 5 plus x. Right there, we have same value as x plus 5. Addition, it does not matter what order the two numbers in. So x plus 5, you will get the same value as 5 plus x. And again, last one down here is subtraction. We have 5 minus x, represented by 5 subtraction sign x. Unlike addition, you cannot actually switch the order of these values. So you cannot put x in front of 5 and get the same value at the end. So x minus 5 does not have the same value as 5 minus x. Again, going on to the next slide, please feel free to pause at any point. We're going to look at an example of evaluating a variable expression. So you will evaluate each expression when n is equal to 4. We have n plus 3 here. We're going to substitute 4 for n, and then we will try to simplify. So simplifying is when we try to solve the problem or perform as many of the indicated operations as possible as early as we can. So just try to break the problem down and just make it as simple as you can. So if n is equal to 4 and we have n plus 3, then we will substitute n for 4. We'll substitute 4 for n. We'll get 4 plus 3. 4 plus 3 is equal to 7. Next problem, we have n minus 3. So substitute 4 for n. We'll simplify. Take that n, put a 4 in. Instead of having n minus 3, we will have 4 minus 3. 4 minus 3 comes out to 1. So pretty simple, no problem so far. I'm going to go on to our next set of examples. So right here, if we have x is equal to 8, 5x. Now remember, when you see the number right in front of the variable, that is a coefficient. What that means is 5 times x. So 5 times x, we're going to substitute 8 for x and simplify. If I have 5x, 5 times x, multiplication is being represented here by the parentheses. 5 times 8 is 40. So using parentheses is the preferred method to show multiplication. Additional ways to show multiplication are 5 with a dot in between 8 and 5 with the x representing multiplication. Personally, I think that the dot makes more sense in a lot of situations, but the parentheses are going to make things nice and clear. So if you'll notice the parentheses, there is no operation symbol in between the 5 and the 8. The parentheses alone let you know that that's multiplication. So again, if x is equal to 8 and I have x divided by 4, I'm going to substitute 8 for x. So I'll have x divided by 4. Really, it is 8 divided by 4. 8 divided by 4 is 2. So nice and simple answer. But remember that our division can also be represented with fractions. So fractions are easy for algebra. Makes things a lot simpler. I personally think that fractions are going to be, really beneficial to you. So instead of doing x divided by 4, we could do x over 4. So x over 4, 8 over 4, we would get 2. So you can just make it into a fraction. All right, I'm about 99% sure that this is our last slide for the presentation before we went into some examples that we did with our classwork. No, actually, you know what? I have one more set of examples. So I'll go through this with everyone, and then this will actually be our last slide for the day. So final example here. We're going to evaluate these expressions if x is equal to 4, y is equal to 6, and z is equal to 24. Actually looking off screen here, I'm getting some notifications on my phone, so I'm going to put that on do not disturb. Sorry about that. So if x is equal to 4, y is equal to 6, and z is equal to 24. First problem right here, I have 5xy, same thing as 5 times x times y. So some multiplication here. We're going to substitute 4 for x and 6 for y. So 5xy is the same thing as 5 times 4 times 6. 5 times 4 you will get 20. 20 times 6, you will get 120. So 5xy, when x is equal to 4 and y equals 6, is equal to 120. Second part right here, I have z over y. Now remember that fraction is going to be division. So if I have z over y, I'm going to substitute 24 for z and 6 for y. So I'll get 24 over 6. 24 over 6, when you divide 24 by 6, you will get 4. So the 4 right around here seems like it has come in unfortunate place right next to that y. My mistake, folks. But yeah, the answer right there is going to be 4. So I appreciate you taking the time to go over this again with me. Hopefully this has been helpful. Let me know if you would be interested in more of these recordings in the future. This is something I just want to try out, and I think I like it. So yeah, let me know, and take care.